Hello students, today we will going to discuss sum of infinite series when modulus of r is less than 1. That means r lying from -1 to 1. One thing you have to take care that this formula we are discussing is very much specific for this condition, that r is less than 1 and greater than -1. As n tends to infinity, r to the power n tends to 0. So this is the formula we have derived earlier, s equals to a 1 minus r ki power n upon 1 minus r for sum of a geometric series for n terms. So n tends to infinity, rn tends to 0 with this condition, r greater than -1 and less than 1. So we will be left with sum of infinite series will be a upon 1 minus r. Now let us see one question. The nth term of a series is given by 5 into 1 by 2 ki power n. We have to find the sum of an infinite series. That means you have to find s infinity, and we will apply the formula a upon 1 minus r. On applying the formula, first of all we have to identify the value of a. A is nothing but a first term, means we will get the first term by putting the value of n equals to 1 in this expression. So we will get how much? 5 by 2. And r is how much? R is 1 by 2. You can see it because if you divide two terms, the next term with the previous term, you will get r common ratio, that is r equals to 1 by 2. Now applying that formula, s infinity, you will get 5 by 2 upon 1 by 2. You will get 5. Now let's see another question. Express 0.3 bar into a GB, then use the GB to express 0.33 in fraction form. As you know, 0.333, you can write it in this form: 0.3 plus 0.03 plus 0.003. And if you write it in a fraction form, you can write this way also, means retaining 0.3 in numerator and writing this expression with 0.3 numerator. That means you have to divide it by 10, and this you have to divide it by 100, and you will get this in this form. Now what you have to do is apply the formula, because this is infinite, this is going infinite. So we will apply the formula. So before applying the formula, let us identify first term a, that is 0.3, and r is how much? 1 by 10. Now applying the formula, s infinity equals to a upon 1 minus r. You will get how much? 0.3 upon 1 minus 1 by 10, or simply 0.3 upon 9 by 10, and you will get 0.3 into 10 upon 3 upon 9. So we will get 3 by 9, that is 1 by 3 in lowest form. So we have write it in fraction form, though it is also right, but the best possible answer is 1 by 3, and we should bring out in lowest form. And if it is specifically written, then we must have to bring it down to the lowest form. Now let's see one question, which this is a question came in past years. P1. A geometric progression has first term a, common ratio r, and sum to infinity s. A second geometric progression has first term a, common ratio 2r, and sum to infinity 3s. Find the value of r. So means s equals to a upon 1 minus r and here 3s equals to a upon 1 minus 2r, applying the formula of sum of geometric infinite series. Let's say this is equation 1 and this is equation 2. Now what we will do, we'll divide equation 2 with equation 1. We'll get 3s upon s equals to a upon 1 minus 2r upon a upon 1 minus r. A will cancel out, s will cancel out, so you will be left with 3 equals to 1 minus r upon 1 minus 2r. Now cross multiplying 1 minus 2r, both sides you will get 3 into 1 minus 2r equals to 1 minus r, and simply solving 3 minus 6r equals to 3 equals to 1 minus r. So we'll get how much? You will get 2 equals to 5r, that is r equals to 2 upon 5. So this is your answer. So let's see another question. A geometric progression which all terms are positive has sum to infinity 20. The sum of first two terms is 12.8, means some geometric series is given and its value is given 20. That means this is equals to a upon 1 minus r. And this is, let's say, equation 1. Another equation we can find it out from where the first term plus the sum of the first two terms, means a and a r, equals to 12.8. This is equation number 2. So equation 1 we can write it down like this: 20 1 minus r equals to a, and here taking a common we will get 1 plus r equals to 12.8. So now replacing this value with a, that is 21 minus r with a, and then remaining 1 plus r. This a we have replaced with this entire function. So we will get how much? 12.8. So now solving the entire this equation, you will get 20 1 minus r square equals to 12.8. So 1 minus r square equals to 12.8 upon 20, that is 6.4 divided by 10 equals to 0.64. So r square you will get it 1 minus 0.64, that is 0.36. So r will be either 0.6 or minus 0.6. Has this line now becomes important that all terms are positive. So when all terms are positive, so that means this cannot be negative. So remove this. Find the first term of the progression, means you have to replace the value of r here. So we will replace this 20 1 minus 0.6, means how much you will get? 20 into 0.4, you will get 8. So this is the first term, we got the answer. The answer is a equals to 8. Now if you want to cross check it, you can cross check it. A equals to 8 and plus AR means 8 into 0.6, 0.6, you will get 4.8. So 8 plus 4.8 you will get 12.8. So this is the way you can cross check also. So with this we'll end here, and hope you understood. Best of luck.